wabarakatuh. Good morning, ladies and gentlemen, and all of the participants in online seminar today. Greeting for me, my name is Hanan Azara Shafina. I'm a student of Faculty of Marine Science Department of Aquatic Resources, and today I'm so honored to be your Master of Ceremony, and we are pleased to welcome all of you to our online seminar, and the theme that is maintaining sustainable inland fisheries in watershed development. And ladies and gentlemen, before we start today's event, let me send greetings to the Honorable Prof. Insinyur Triwinarni Agustini, MSc, PhD, as our Dean, Faculty, Fisheries and Marine Science, Universitasdiponegoro. And the second one, we have Dr. Insinyur Suryanti, MPI, as the Head of Departemen Aquatic Resources. And the fourth one, we have Churun Ain, SPI, MSc, as a Secretary of Aquatic Resources Management Study Program. And the fifth one, Dr. Aninditya Sabdaningsih, SSE, MSc, as a Head of Postgraduate of Aquatic Resources Management Study Program. And the sixth one, we have very special speaker, Joachim B. Bretzel, MSc, PhD candidate, and Dwi Adminarso, PhD candidate from Charles Sturt University, Australia, and Mr. Kuku Prakoso, SPI, MSc, as our moderator of online seminar today. And last but not least, once again, welcome to all of the participants of online seminar today. Before we start, let's start this event by praying, and it will run without any obstacle. Pray based on individual belief. Begin. Okay, finish. Now the committee will help me to share screen our rundown for online seminar. Okay. Allow me to tell our rundown of our online seminar today. And the first one, we have opening by Master of Ceremony and sharing rules for participants. And the second one, we have singing Indonesia Raya as the national anthem of Indonesia. And the third one, we have opening remarks from the dean. And the fourth one, we have photo sessions. And the fifth one, we have video profile of Faculty of Fisheries and Marine Science. And the keynote of talk from Joachim B. Bretzel, MSc, PhD candidate. And the next one, we have talk from Dwi Adminarso, SPI, MSc, PhD candidate. And we have discussions, and the last one, we have closings. Okay, next. We have move on to the next agenda. I would like to invite all of us to sit properly while listening Indonesia Raya, the national anthem of Indonesia. And the committee will help for share screen.
Indonesia
Thank you so much for the committee for the help. Move on to next agenda. We will have an opening remarks by our Dean, Faculty Fisheries and Marine Science, Universitasdiponegoro, Prof. Insinyur Triwinarni Agustini, MSc PhD. For Prof. Insinyur Triwinarni Agustini, time is yours.
Excuses, Prof. You are still mute.
Okay. Okay, thank you very much to the Master of Ceremony. Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thanks to God for giving us to for His blessing and grace, so we can meet each other virtually, joining this webinar for this very wonderful morning. So to everyone, a very good morning, and I also would like to thank you to our distinguished speaker for today, Mr. Joachim Bretsky, MSc PhD candidate, and also Dr. Adminarso, Dwi Adminarso, PhD candidate, from both of them from the Charles University Australia. And this morning was the webinar, which is mainly we delivered for undergraduate student, but this time we also involve some participants from different level for the student and also from different institution. So I would like also thank you very much to the head of Department of Aquatic Resource Department, Dr. Suryanti, and the team, and all the participants who joining this webinar for today. The webinar taken the topic was very interesting, maintaining sustainable inland fisheries in watershed development. Undip, especially for the Faculty of Fisheries and Marine Science, even though we now have the Center of Excellence for Coastal Region Eco-Development, but we actually pay attention also to develop for the inland fisheries aquaculture. So in this time, about the inland fisheries and the topic related to it, so we would like to ask the distinguished speaker to share and maybe give us any suggestion about the development of our inland fisheries in Faculty of Fisheries and Marine Science, especially in Diponegoro University. Therefore, by saying Bismillahirrahmanirrahim, we do hope that this webinar will be useful, and we do hope also for the fruitful discussion for today to everyone who joining. So I think this is all of my expects and also faculty expect for the fruitful discussion by joining this webinar. Thank you very much and have a wonderful time for this seminar. Successful for everyone. Thank you very much and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much to Prof. Insinyur Triwinarni Agustini, MSc PhD, for a great opening remarks for our online seminar today. And next agenda, we will have an photo sessions. I kindly asking for every participants in this meeting can open their camera so we can capture this moment for a second and for our documentations. The committee will help me to take a picture. So maybe all of you guys can open your camera and smile brightly. Okay, for the committee, please help me for the photo sessions.
I will take a picture. 1, 2, 3. Next, 1, 2, 3. Insert. 1, 2, 3, 4. 1, 2, 3, 5. 1, 2, 3, 6. 1, 2, 3, and 7. 1, 2, 3. Thank you.
All right, thank you so much for the committee for helping me to have these photo sessions. And we will move on to our next agenda, that will be video play of video profile of faculty of Fisheries and Marine Science. Okay, thank you.
Indonesia is an archipelagic country with one of the world's richest reefs and longest coastline. This gives Indonesia an immense potential in the fisheries and marine sector. The Faculty of Fisheries and Marine Science of Diponegoro University has been among the leading marine research institutions in Indonesia, since it was first established as Fisheries Department in 1968 and officially became a faculty in 1994. The Faculty of Fisheries and Marine Science is located in the Central Java province. The main campus, where main activities take place, is located in the capital city of Semarang. The second campus, also known as the Marine Science Technopark and Coastal Development Laboratory, is located in Jepara Regency. The vision of the Faculty of Fisheries and Marine Science is to become an excellent faculty in the field of fishery science and tropical marine in the year 2020. In pursuing its vision, the Faculty of Fisheries and Marine Science missions are to provide a high-quality education in the field of fisheries and marine science, engage in scientific research and publications, produce intellectual property rights, provide community services in fisheries and marine science field, implement a professional and accountable system, and empower students' activities to achieve the complete graduate qualifications. There are 6 departments in the Faculty of Fisheries and Marine Science. The first one is Aquatic Resource Management, Capture Fisheries, Aquaculture, Marine Science, Oceanography, Fish Product Technology. The faculty provides numerous facilities to support all study and research activities, from student discussion spaces, library, and integrated laboratories. We provide aquaculture lab, biotechnology lab, chemistry lab, hatchery, and geographic information system lab.
The excellence of Faculty of Fisheries and Marine Science is proud to contribute in fisheries and marine field through artificial patch reef in Panjang Island, Jepara, provides information to the public of Semarang as a reference data for sea level rise on the coast with drop calendar. In our faculty, we collaborate academic and experimental learning to give the best experience of learning. The faculty have 16 student activity units divided into several fields like art, sport, religious club, research, student executive board, and student senate, where students are allowed to become more involved on campus, increase leadership, social responsibility, and their personal development. One of the organization, Kesemat, received an achievement as the best ASEAN student organizations in 2016. Faculty of Fisheries and Marine Science conducts activities in international scale, such as International Tropical Summer Course and International Conference on Tropical and Coastal Region Eco-Development. International Tropical Summer Course is an event for international students from partner universities to learn about coastal ecological preservation, and coastal biota in Semarang and Karimun Jawa Island. International Conference on Tropical and Coastal Region Eco-Development is an annual international seminar event that aims to promote and disseminate research results.
The Faculty of Fisheries and Marine Science aspire to take a role in strengthening the marine and fisheries field in Indonesia through the application of knowledge from our graduates to achieve and bring positive impact to the
Okay, thank you so much for the committee for helping me. That's such a wonderful video of our profile. Upcoming next event to move our agenda. Finally, we move into the key point of today's sessions. That is talk from Joachim B. Bretzel, MSc PhD candidate. But before that, to kick off today's online seminar, we are pleased to have our resume CV, our moderator. Maybe committee will help. All right, okay. So here we are pleased to have with us Mr. Kukuh Prakoso, SPI MSE, our moderator, to lead the course discussions into the first sessions. Without any further ado, let's get to know our first moderator. As you can see from his resume, Mr. Kukuh Prakoso is a lecturer in Diponegoro University, and he was undergraduate Department of Aquatic Resources Management, Universitasdiponegoro, and he just graduated from Magister Department of Coastal and Marine Resources Management in IPB University, and the research interest in social ecological system, coastal management, seagrass ecosystem, coastal and marine policy. So for finally, may I request Mr. Kukuh Prakoso to kindly occupy this Zoom meeting screen. Time and screens are yours.
Yeah, thank you very much, Hanan. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Good morning from Indonesia, and maybe good afternoon in Australia to Mr. Joachim and Mr. Arso. The Honorable, the Dean of Faculty of Fisheries and Marine Science, Professor Insinyur Triwinarni Agustini, MSc PhD, the Honorable, the Head of Aquatic Resource Department, Dr. Insinyur Suryanti, MPI, the Honorable, the Secretary of Studi Program of Aquatic Resource Management, Ms. Kurun Ain, SPI MSc, and the Honorable, the Head of Postgraduate Program of Aquatic Resource Management, Dr. Aninditya Sabdadinsih, SSC MSc, and all of participants of this online seminar, and the Honorable, the two remarkable speaker, Mr. Joachim and Mr. Arso. Ladies and gentlemen, I'm Kukuh Prakoso, the moderator of today's online seminar. It's my honor to see all of you here and welcome to this online seminar. The topic of this online seminar is maintaining sustainable inland fisheries in watershed development. As we know, most of the rice production is carried out in the flooded swamps because it contains fertile and productive soil. As a result, flood swamps are extensively developed with flood control and irrigation system to increase rice production and prevent crop flooding during seasonal flooding. Well, such flood control and irrigation systems are advantageous for rice cultivation. They hinder important immigration routes for fish seeking access to fish breeding and foraging sites. While these programs provide riverine communities with a more stable income for better rice field, they risk losing income from fishing and source of essential protein and nutrients, has the potential to cause the loss of primary livelihood system, malnutrition, and social disruption. The protein from this fish cannot be replaced with other agricultural products. Therefore, maintaining the sustainability of the fish life cycle through the provision of migration route is very important to maintain the availability of this fishery product. Researchers from Charles University developed a research project that is expected to be a solution to that problem. A research pilot project has been developed in the Sumatra area under the coordination and collaboration between CSU, the Ministry of Public Works of Indonesia, Director General of Water Research, and ICEAL, the Australian Centre for International Agricultural Research, through the fish ladder or tangga ikan concept. This concept is not widely known by the government, academic, practitioners, and students in Indonesia. So that socialization and sharing related to the concept of fish ladder or tangga ikan is very necessary to be adopted and developed for the preservation of inland fisheries and saving fish migration routes. Therefore, at today's online seminar, we invited two remarkable speakers from Charles University who have been and currently conducting research on this topic. So at this online seminar, we will discuss about this topic. And before we start, information for all participants, we apologize for today's online seminar. The material from two speakers today cannot share with the participants because there are some data and information related to their doctoral study that have not been published. And to all of the participants who want to ask question can write your question in the Zoom at the chat box column and YouTube live chat, or you can ask the speaker directly through the raise hand feature in Zoom meeting during the discussion session. And don't worry if you won't ask the question with Bahasa. Before we start this online seminar, allow me to read the CV of the first speaker. Ladies and gentlemen, the first speaker is Joachim B. Bretzel, MSc PhD candidate. His work at Department of Primary Industry and SW as Fisheries researcher. He has received his bachelor degree in 2017 at Technical University of Munich with majoring landscape planning. Then he got a master degree in 2009 University with majoring landscape planning. And now he is PhD student at Charles University, Australia. And next. And here are some of the recent publications that have been written by Mr. Joachim. And now, please welcome to the first speaker, His Excellency Mr. Joachim B. Bretzel, MSc PhD candidate, to deliver your presentation. You have about 30 minutes to present, and now the time and screen are yours.
Thank you very much, Kuku, and thank you to everyone for this warm welcome and nice words. I'm very happy to be here today and to talk about my research. So I share the screen now. So you can see.
Yes, we can see.
Yes.
Okay, awesome. Good. Okay, today I'm talking especially about the topic irrigation diversions and the problematics they bring, but also the solutions that are developed already against this. Okay, here we go. Yeah, my name is Joachim, and at the moment I'm in Australia. So many of the examples I will talk about are from Australia, but I also try to bring in some international examples. So as we all know, there is a high decline of fish during the last 100 years, especially, and also, yeah, especially riverine fish are affected of this decline. And the interesting aspect is this is not only regardless their commercial use, so also species which are not of commercial interest are declining. And as we can see on this on this graph here of a very important study that showed that the riverine fish species declined about 76%. This study was done on 247 species and showed that there is a strong decline. So finally, we can say riverine fish are one of the world's most threatened taxa, and on the other hand, they're very important for economy and fisheries. So what are the reasons for this decline? There's not only one reason, there are several things coming together worldwide. And a big thing is the competition about water. Water is a limited resource, and yeah, we need it. It's essential for every one of us every day. Another important factor is habitat degradation, and therefore altered hydrology and flow regulations. So yeah, we affect the rivers worldwide because we need the water, but this affects the ecosystems and fisheries, such as migration barriers. Dwi Admin Arso will talk more about that later. Yeah, and also fisheries overexploitation. When we take more, then that is not sustainable anymore. But also water pollution, global environmental change, such as climate change, or non-native species are reasons for the decline. And last but not least, the global irrigation practice, including the extraction of water and organisms, and also the habitat change and the building of dams contributes highly to this decline. But on the other hand, irrigation practices is something important for all of us. So more than 50% of global fresh water is diverted from natural waterways for our needs. And there is an increased global demand. The population is growing and we need the water. So but on the other hand, it has impacts on society, ecosystems, and also the ecosystem services, as well as the riverine biodiversity. And also direct impacts on the aquatic organisms, such as fish and their populations. And as we can see on this graph, the demand is rising, and agriculture by far needs most water worldwide. And yeah, with higher tendencies every year. And yeah, we have to think about that when we think about protecting our waterways. So how do we take the water usually out of the rivers beside building dams? There are different ways of diversion for irrigation. There are pump diversions, so just simply pumps that sucking out the water where it is needed. Gravity-fed diversions, just some channels that go away from the main river and deliver the water where it is needed. Or other surface irrigation diversions. This picture actually is from Indonesia. And yeah, there are different ways like basin irrigation or flooding, as already mentioned for rice. So I will focus today on pump diversions and gravity-fed diversions, because other ways of diversions can be actually good, because some of them providing habitats for fish, as studies showed. But whilst gravity-fed diversions and pump diversions can have negative consequences for the fisheries. Why is that? So first of all, I will give you the example of the Murray-Darling Basin. This is where I do my research in Australia, and it's also called the food bowl of Australia, because there's a lot of agriculture. It's producing almost all of Australia's rice and cotton, and also high amounts of crops, livestock, and horticulture. So agriculture is very important in this area of Australia. And 1/3 of the annual agriculture production in the Murray-Darling Basin is irrigated. So about 30.6 billion liters are needed every year for watering, and taken off the 21 rivers there in the basin. So when we watch New South Wales in Australia, has more than 4,500 irrigation pumps of different sizes, and it is estimated that millions to billions of fish are extracted off the water as well. Yeah, and from the main rivers. So and we also can see how the consumptive water, how much goes into agriculture. This, on the other hand, is a hot topic, because there's also fisheries, there's also recreation. The rivers deliver different services, and because of the high need of water, there were many conflicts already, especially in a country as Australia, where it is very dry often and the water is limited. So yeah, this is a highly discussed topic in the media as well. On the one hand, the important economical factors of agriculture, on the other hand, fisheries, and the water that is needed for other things as well, to have healthy rivers. And in the Murray-Darling Basin, 46 native fish species appear, some of them only in this river system, and some of them are also threatened species. There are also 11 non-native fish, like European carp. And until now, there's only 10% left of the pre-European settlement of native fish. And irrigation also has its impacts on that. So when we want to, in fisheries, when we want to protect fish populations and species, it's important to take a look on the whole life cycle of fish. Often the mistake is done that people only focus on one life stage of a fish to protect it, or fish, but we have to take a look on all life stages, which could differ during the life of a fish in needs. But this is very important to do a successful species protection and fisheries management. So yeah, the eggs, the larvae, the juvenile and the adult life stages have to be considered when we are looking for fish protection. And this is also the case when we're talking about irrigation, because the problem in Australia and many other countries is that water diversions extract the organisms of the rivers, but also affect highly with dams and pumps the natural flows. So the spawning habitats, the recruitment and the adult habitats are affected of this needs of water and of these measures. On the other hand, as I already said, the direct extraction of organisms plays a high role, because the pumps kill the fish directly when they get into the systems, or they get killed by stranding on the fields or in the channels. What is bad when they are in the channels, I'll show you. But yeah, it's important to say that all life stages are affected, from big fish to juvenile fish to eggs, all can get extracted out of the river, and this in high numbers. So this affects the fish populations. Yeah, so when the fish end up in the channels in Australia, as we can see, this looks not like a fish habitat where fish can breed or live for a long time, because it is an unstable environment. We have hot temperatures, very high flow, and most fish can't survive in these irrigation channels. On the other hand, the most of the channels are dry the most time of the year. So these fish are lost from the rivers and from the main population. On the other hand, they are more exposed to predators, includes human, but are not as protected as in the main habitat. There are some channels which have water all year long and provide habitats, but the most of them are not suitable for fish. What is the consequence of this? So fish of all size classes are unprotected against the entrainment. When I talk about entrainment, I mean the extraction of fish out of the river into the channel, and are entrained into this extracted water where they cannot live and are lost from the main population. So they are permanently removed from the main river systems. So this is a study I did in an irrigation channel in New South Wales, where I just investigated what gets extracted by the pump and is taken off the river populations. And we had fish in all size classes, as you can see. from juveniles to larvae to eggs and very high amount of other aquatic animals such as freshwater shrimp or crayfish, all extracted off the river, and they would die in this channel and would not survive. So they're taken off without any use. This is an international problem, not only in Australia. So especially in America, Northern America, when we see there are more than 150,000 diversions, and imagine all of them suck out hundreds of thousands of fish every day. This affects, of course, the populations. But in America, this problem was already seen in 1929, and they started to do something against this. And especially, also Canada and the United Kingdom have a long history of protecting fish at water diversions because they see we're losing fish. This affects the population, so we have to do something against this. And they developed, first it was a bit not very successful, but then they developed fish protection screens. So this is a technology that should avoid that fish get extracted off the river, but it is still able to get the water that is needed. So when I'm talking of a fish screen, I'm talking of a physical barrier that is designed to exclude fish, debris, leaves, and other aquatic organisms when water is extracted for human use, and the water is delivered. That's very important, where it is needed. So fish screens, I'm not an engineer, but there's a high variety of fish screens, as you can see here, for small pumps up to big offtakes. There are different ways, and they all work a bit different, but they all have the same function. They reduce the velocity. So when a fish is at a pump, where a small pump, for example, where the flow is 1 to 3 meters per second, it has no chance to escape that. When we put a fish screen on, the velocity is reduced because we have a higher surface, and then the fish can escape and is not get sucked out of the water. Some of these screens also have self-cleaning measurements, as we see on this cone screen or this drum screen. Yeah, but I don't want to talk too much of that. That's the engineer, for the engineers. I just want to give you some examples also of very big fish screens. This is in California, the Sacramento River. A few years ago, they put this huge fish screen on. So we see the spaces, and then you see the actual screen. These are 1.7 millimeter mesh size, what is very small, self-cleaning. And on the other hand, we can still, or they still take 30 million gallons of water daily without harming any more fish, because before that fish screen was there, millions of fish were sucked out there and lost from the population. Another interesting example is the Taki River fish passage screen at the Derby Dam. So this is interesting because besides it's a fish screen, it's also working as a fish, kind of a fish ladder at the same time for fish migration. So the water is, the fish swim, and the water that is needed for the irrigation goes below them through the screen. And the fish can migrate down the river. This was last year finished, and is a very interesting example of a very big fish screen. And now back to Australia, I talk about a fish screen that is big smaller, but on the other hand, it's the first large one in New South Wales. And it's a cone screen. So the water goes through the cylinders with a 3 millimeter mesh screen. And because the surface is so big, the fish won't get extracted. That's the idea of the fish screen. And I'm doing some studies on this and will test the efficiency of this screen. I don't have enough data yet to give some final results out, but it's very interesting, and the screen absolutely has effects on the entrainment rate of fish. Yeah, but now the question, why do we put on a fish screen and not just why do we not just put on a little bit of mesh, and it should work as well? So the actual important thing of a fish screen is not the mesh. It is that we have a higher surface to reduce the velocity at pumps and at channel offtakes. So if we put on only little bit of mesh wire, we see after a while, because of all the fish and debris, it will be blocked, and the farmers have to clean it, and we have heaps of dead fish as well. So this is not very effective. This is not what we want. And the modern fish screen, because of the higher surface and the reduced velocity, we don't have that problem. So nothing is sticking on it. And on the other hand, when they are self-cleaning, it's even more effective. So that's why we are talking about a technology that is very interesting to protect fish. So finally, modern fish protection screens are the effective solution for protecting fish and aquatic biota from entrainment by having a large surface area and reduced velocity. Also, we have small mesh sizes that fish don't get extracted, and some of them are self-cleaning. And the important thing is, the aim is to protect all life stages, from eggs to larvae to big fish, as we can see on this picture here, that you're not getting sucked out into the irrigation channel. Yeah, and that's the main challenge actually, because the early life stages, so the eggs and the larvae, the small ones, they're one of the biggest issue for fish conservation, because they're getting sucked out in very high numbers. Some of the bigger fish, they can escape from the pumps or don't fit, but the small fish, that's the hot topic, and also hard to screen, of course, because they are small. So when we're doing fish protection screens, just because it's done in America for more than 100 years, doesn't mean, we just can take their technology and adapt it to Australian rivers. This is like fish ladders. So they built fish ladders for barramundi in Australia and realized, we took it from America. This is made for salmon. A salmon can jump high, but a barramundi can't. So in the end, we have to look for the water body when we do build fish screens and in general fish protection. The species and the water body, because they differ worldwide. The flow, the ecosystems, and the fish species. For developing a fish screen, it is important to take a look on the river where we put it on. It is important to take a look on the fish community and also the target species, which we want to protect, and also the position and the outtake type. So is it a pump, or is it a pump, or is it a gravity fed channel? And actually optimizing the velocity is in the end more important than the construction material. Construction material is also important, but it is not as important as the velocity. This is what different lab trials showed as well, as we can see on this picture. And yeah, other benefits of fish screens, Australia and also other example is that the outlets are no more blocked, as we saw in this picture. So it's not necessary to clean the pumps and clean the sprinklers. In Australia, they use a lot of sprinklers for watering. These are all blocked by leaves and aquatic animals that were sucked out. This is not necessary anymore then. And yeah, in the end, lower energy for pumping, what also brings economical advantages. So it's a win-win for fisheries, but also for the irrigators. Yeah, now, when I'm talking about this, of course, I want to talk about Indonesia as well, because as we already heard, 82% of the rice production is irrigated in Indonesia, and irrigation is a very important topic there. So 6.2 million hectares are served by irrigation, and there is a massive expansion in irrigation infrastructure planned over the next 20 years. On the other hand, we have inland fisheries that is important for food security, proteins, and also thousands of jobs and the supply chains. So like everywhere in the world, it is in the end the aim for us to protecting the fishery resource base from the impacts of the irrigation infrastructure, which is also important. And that's quite challenging. Yeah, as I already said, we cannot just transfer the technology and measures from other countries to our countries like they did it in Australia. So the same thing happened with the fish screens. They took American fish screens and thought, oh yeah, they should work for Australian species as well. But then it figured out, well, these screens are also built for salmon, for trout, and Australian species are very slow swimming species, have a different kind of spawning of recruitment, and the same as with Indonesian species probably. So it is very hard to say, okay, this measure is working in another country, so we can use it in our country as well. We always have to look on the river and on the fish before we do this. So an Indonesian river, as here seen on the picture, might be completely different again to Australian rivers. So yeah, they need their own research, and especially concerning irrigation, there is not much done yet. Also in Australia, it's a very young topic. In America, the research on fish entrainment has very long tradition already, and they had a long time to develop their screens, but they never really made kind of managing how successful they are. And in Australia now, they started a few years ago with screening, and this is very interesting because now they can observe very good how successful are these measures, how effective is it, and the same might apply in other countries. So I have a very good example from Indonesia, the Pejaya Dam, that has a fish ladder, and this fish ladder ends up right next to an irrigation channel. So when the fish swim through the fish ladder and end up in the river, the chances are very high that they end up in the irrigation channel and not in the river where they have their spawning habitat, where they want to migrate. So for example, in this case, a discussion about a fish screen might be helpful because it could have positive effects on the fish population in the river. Then, yeah, many irrigation projects are planned, and such as dams, irrigation channels, and offtakes are planned, and but also proceeding without considering potential effects and impacts on fisheries. The problem is also there is not much known about it. There are almost no studies about it, except the one I have listed down there, and maybe a few more. But there is a lot. There is a huge knowledge gap about this for maintaining fisheries, and it is important to understand how the irrigation schemes affect the fish in Indonesia and fisheries, and also to develop effective solutions for that. And it might be also worth considering physical barriers such as screens to divert fish away from areas like offtakes or pumps that might have big impact on the fish population in a river, and get them away from this area of concern. Then another thing I want to talk about, because it might be interesting for today, is fish farming in irrigation channels. So as I showed you from Australia, many of them are empty for the most time of the year and only have a short time, a lot of water in it. But in other countries, like Indonesia, for example, successful aquaculture operation in permanently flowing irrigation channels are already existing. So I mark permanently flowing because that's the important and also difficult part of it. They always need water in it. And when this is the case, it could be thought that to keep fish like carps, tilapia, catfish, or snakeheads, which are all considered to be pretty tough species and not very sensitive, so they can be kept in irrigation channels. And this is an interesting aspect thinking about fish farming and aquaculture. But, and there is a but, irrigation channels often have very fluctuating conditions. They are unstable and unpredictable because, of course, the main the main need of irrigation channel is to get water for agriculture. So when they need more water, of course, this affects the channel and the water quality, such as oxygen levels, water temperature, and yeah, the water in general. So yeah, this might make it difficult, but always depending on the situation again. It could be it could work, and it could give some positive results of aquaculture in irrigation channels. But yeah, it might take some effort. On the other hand, this has actually not much to do with the protection of the fish in the rivers, because even when we do this aquaculture and affect the fish populations in the rivers, yeah, it's a nice additional thing to know and to think about, but it's not the solution to protect the fish in the rivers. Yeah, then I'm already at the end, and just would like to thank my supervisors, Professor Lee Baumgartner, Craig Boyce, and Professor Robin Watts, as well as the Department of Primary Industries and the people who support me financial, and also Dewey and Dr. Katie Doyle, as well as the rest of Lee Baumgartner's team for all the support and the help on my studies on this interesting topic. And I'm happy now for discussion and yeah, talk about it if you have any questions. So thank you very much.
Yeah, thank you very much, Mr. Joachim, for giving such informative and interesting presentation today. It's nice knowledge. From Mr. Joachim presentation, we mentioned that we talk about fish conservation and irrigation diversion problematic and solution. And he mentioned and informed to us that how the effect of development in inland fisheries and how to give the solution with the equipment and technical or engineering to have the fish ecology. And now, ladies and gentlemen, we continue to the second speaker. Before we continue to the second speaker, allow me to read the CV of the second speaker. Okay, the second speaker is Mr. Dwi Atminarso, SPI MSc PhD candidate. He is worked at Research Institute for Inland Fisheries and Fisheries Extension at Ministry of Marine Affairs and Fisheries, Republic of Indonesia. He has received his bachelor degree in 2008 at Universitasdiponegoro with major in Aquatic Resource Department. Then he got master degree at the same university with the same major, and now he is a PhD student at Charlotte University, Australia. His research interests are about fish species and fish migration, invasive species and genetic population and phylogenetic. And next, and here are some of the recent publications that have been written by Mr. Dwi Atminarso. And Mr. Dwi Atminarso, or Mr. Arso, will present about the importance of maintaining river connectivity and fish waste consideration. Now, please welcome to the second speaker, His Excellency Mr. Dwi Atminarso, SPI MSc PhD candidate, to deliver your presentation. Same with previous speaker, you have 30 minutes to present, and now the time and screen are yours.
Thank you so much, Mas Kuko, and I'd like to express my great gratitude for the invitation to this webinar and the Honorable Dean Faculty of Fisheries and Marine Science, Professor Tribunani, and then the Head of Aquatic Resource Department, Dr. Suryanti, and then the Secretary of Aquatic Resource Department, Ibu Churun Ai, and also Pak Kuko as the moderators, all the lecturers and staff and all the attendees who participate in this meeting. Thank you so much. And today I would like to talk about the importance of inland fisheries that faces challenges because of the development of water infrastructures in Indonesia. So let me share the screen. Can you see my screen?
Yes, Mr. Arso.
Okay. Today, Joachim has talked about the irrigation that impact fish movement, that so many fish extracted to the water and the irrigation system and cannot continue their life cycle. And in this moment, I will talk about how to maintain the river connectivity and also to consider the fishway construction in infrastructure development, because it is very important to maintaining the continuity of fish migration, because we have so many fishes in Indonesia. At least we have 1,300 inland fish in Indonesia, and all those species is require different migration pattern. So we have to consider every single species that habit in our rivers. So my talk will be cover those things: global infrastructure development, main challenges faced by in the inland fisheries, benefit development, and also United Nations Sustainable Development Goals that has been adopted by Indonesian governments, problem and solution associated with water infrastructure development, the importance of inland fisheries compared to other protein source, considering fish species, and also how to design a proper fish species that consider the local need of the local fish community. At least almost 7 million human-made reservoirs has been installed to fulfill the demand for food security, electricity, and many other objectives. And from those, although only 18% the agriculture lands equipped by the irrigation system, but they can contribute 40% for the total crops yields in the world. So this significant contribution that has been provided by these infrastructures. You can see here, those all the dams that has been constructed globally. You can see in North America, there's a massive barriers and also weirs, dams, and many kind of barriers that block the rivers. And also in Europe and in Southeast Asia, China, and also in Africa. But in the recent times, this very changes the development of the dams and weirs more often in developing countries than developed countries. You can see here in South America, Brazil, and then Southeast Asia, West Africa, and including Indonesia. We aim to develop more water infrastructure to meet demand for electricity and also for irrigated more agricultural land. This is some the objective of the development of weir and dams, and also other benefit that lead from this development, including tourism and then water sport and also aquaculture in floating cages. This can create income and also employment, but also create more pressure for local fish community. Hydrological change is one of many pressure that experienced by inland fisheries, including human population growth that lead to habitat degradation, and then overfishing, the use of unfriendly fishing gears such as bomb, dynamite, and then small mesh size of gill net. Also pollution that comes from industrialization and also for domestic that uncontrolled, and also the introduction of invasive species, and it's exacerbated by the climate change that can modify and affects the frequency of drought and flooding. Barriers not only affect the fish migration, but also create a new environment that cannot fit for fishes inhabit there. This barrier can create the Indonesian area in the upstream that, and also in the downstream, this disappearing of floodplain that really important for spawning ground of many species in Indonesia and also another part of the world. So maintaining the frequent flooding in floodplain is really important. So when the water is extracted or blocked by the barrier, then those important area for spawning is disappear, and then many species cannot continue their life cycle, and then extinction will come. So that's the problem and solution that associated with the water infrastructures. Most of the solution has not been reached in Indonesia. Like the barriers can blocking connectivity. We have solution to provide the fish passage, sedimentation in still water in the upstream of the dams, and then water quality and nutrient issue that created from the agricultural land that using fertilizer and then pesticide, and also the habitat alteration downstream and also upstream. And as Joachim talking about the diversion into irrigation system, that so many fish that suck to the irrigation system. That's really complex problem in our river in common. You see here that tons of eels has been cut by the turbine because during the migration from upstream to the sea, if there's no appropriate fishway or there's a block, and then they build the dam for hydropower, and so many fish suck to the turbine and cut. There's a huge amount of money, and also you can see in the weir when fish is able to swim downstream, but they experience barotrauma because of the changes in the pressure during the he passing the spillway, and then the swimming bladder will be swollen, and they cannot longer survive. This is why the inland fisheries is important, because even though only 3% compared to 97% of the portion on Earth, they can contribute. You can see 40% total production is from inland fisheries, both from inland capture and inland aquaculture. It's very huge amount of contribution. Why we need this species? Because fish is need to migrate to complete life cycle for spawning, feeding, and also for refugee. Some fishes require water, so they need to move to the deepest area of the river during the dry season, and also they need to spawning when the floodplain area is inundated. So maintaining river flow is really important. And also this feeding many poor people in a remote area, and this is free access, or I mean that it's free for everyone to catch fish in the river. So if the barrier is installed and then they cannot fish anymore, then they lose their source of protein, source of money, and also cannot feeding their families. This is how look like of fish migration. So they can migrate upstream or downstream. And also they can migrate laterally to the floodplains. And then for spreading, and the eggs is drifting downstream. And also they come back to the main river. But if this river is blocked, they cannot migrate and continue in the life cycles. So we need to provide the fish passage or fish ladder. This is, we can compare between regulated and unregulated river. You can see here that in the left graphs that floodplain is existing here, but when the river is blocked by the barriers, then this floodplain is disappear. But not only that one, but also the impact happening in the people who living around the river. So from our interview in Komering River in Berjaya, we experienced that many people said that they change their livelihoods because no more fish in the river, and many people move from fishing activity to agricultural land. So it's highly impacted to people who depend on the fisheries. This is every single species has their own migration pattern. Some people move laterally to the floodplain and then main river, but others move longitudinally from upstream and downstream. And also the period of every single species is different. So for providing appropriate species, we need to consider every single type of migration of them. This is one of the project that we have in our institute, that we develop research to prevent the invasive species of redfin here. So when they develop the Snowy Hydro 2.0 project, they worry about the invasive species can come across between those dams, because this type of pump hydropower that connected between Tantangara Reservoir and also Talbing Reservoir, when they develop, that will be mixture population, and the native fish that living is very small population here in Tantangara will disappear because of this dangerous invasive species. So we need to provide very good screen that can protect this invasive species, not only the adult, but also the eggs and larvae, as Joachim mentioned before. So those type of fishway that exist in the world, like a full pass and then Daniel's fishway, and lock fishway is for very high dams like hydropowers, and also rock ram is normally for very low head barriers. That's yeah, and normally lock fishway is very expensive to build, and many engineers don't want to build this one because it's just too expensive. But yeah, we have to have a win-win solution when they cannot provide these facilities. This other type of fishway for eels, we call eelway. It's very simple. compared to other type of fishway. This is one of the highest fish lift installed in Stolaven River in New South Wales. It's about 43 meters high. And also in Australia, there's especially in New South Wales, it's mandatory to provide fishway when they build barriers, dams, or where they have to considering the fishway as a solution to maintain fish population. In Indonesia itself, we have thousands of weir and dams that has been installed, and none of them is considered the fishway design. And so far, as we know, only 4 fishway has been installed in Indonesia, and those were not considered the local fish community. They just copied and pasted from North America just for salmon, and we believe that's inappropriate for Indonesian fish. This is some proof of concept that we conducting at the moment in Komering River in South Sumatra province, because there's some evident that the declining population of fish since the development of the Berjaya dams. So before the dam construction, they have 55 species. And then 15 years after the construction, the fish species is declined and then continue after 22 years. And in the recent times, we found that only less than 30 species exist in this river. That's very dramatic decline. This other example in Citarum River in West Java also experienced same things after the development of water infrastructures. Also, other area in Selabung is also part of Komering River, and also Kuto Panjang in Riau province, and also in Central Java as well. Those are dams that equipped by the fishway. The first one is in Berjaya, in Oku Timur Regency. They installed in 1995 from Japanese company from JICA project, and they just copy from Japanese design. And when we assess this performance is not really working well, because the operation rate is very low. So when water is very low, the head loss in the entrance is very high, so it's impossible for fish to jumping. And also when water is very high, all the fishway is flooded. And yeah, this is very important to considering the maybe 10-year series of how high is the water level, and how low is the water during the drought season. So we can design the appropriate fishway. And the second one is Solewana Dam. So they provide fish species, but the very high turbulence and aiming only for eels, even though they have many species in habitat. So there's 3 essential data that we need to provide when we want to have very good fishway design. So we need to know the biology of aquatic biota living in there, and then also hydrology, so including river flow and water level. So we can see here that there's a vary of flow during the years. It's very different every single month, and also it's different with temperate regions. So we cannot just copy it from others part of the world. We need to have research in our countries, in our particular area, to know these patterns. And also when is the peak of fish migration? we need to develop this concept. Then we can create a good fishway. This is the picture of the Sumberdaya Way. So they have, I think, 18 vessels. It's very big construction. The width is 8 meters and the long is 75 meters. And so we assess the performance of fishway by using the trapping at the top of the fishway and also at the bottom of the fishway. So we want to know how many fishes, how many individual, how many kilogram of fish that can find the entrance of fishway and also can ascend and continue to the upstream. So we design trapping upstream and downstream. This one is trapping in the in the entrance, and this one is the top or exit. So this is a video that can explain about how they migrate. So this is when water level is increased, trigger fish to migrate upstream. Most of species triggered by the changing of water flow. When its pressure is coming from upstream, then they provide a cue for fish migration. You can see small fish, they can jump very high. So we need to create head loss that's very low, so small fishes can jump upstream. And also during the downstream migration, they can also migrate to the downstream. So the result of the experiment is we find less than 30 species in this fishway. And even though this is not the peak of fish migration, but we still collect 1,000 of individuals, and also about maybe 30 kilograms of fishes. And also we found evidence that many species is mature. Like this one is, I think is ready to hatch, and so it's evident that they migrate for spawning. So this is important to provide the ways for fish migrate upstream and downstream. Then we can protect their life cycles. We also measuring head loss to know the operational of this fishway, and we can see here that the turbulence is very high, so the operational range is very low, and this is not perfect fishway for Indonesia. So this operational consideration to be known when we develop a fishway. So are the fishes arriving to the area of the barriers? And then are the fishes finding the entrance? So here is the entrance. So they created a flow here. So they create a notch to develop more flow in this corner. Then fish can find it because they trigger by the flow. Also, is the fishway is performing well. Can fish passing those baffles? So baffle is every single column in this fishway. And also, are the gate setting is correct? And how many water we need to release to downstream? Because if there's not enough water, then we cannot attract fish to move here and found the entrance. also what's the best time to fish to migrate? Is it in January, on the early of year, or end of the years? We have to decide. We need to do research to know their migration pattern. So this is study from Cloud PDR that conducted by my supervisor, Dr. Lee Baumgartner. They found that after 5 years and for higher productivity wetland, they will gain the so this one is economic return after they providing the fish weight. So without fish weight, there's declining and the fish catch is very low. But if we provide the fish weight, you can see here that after 5 years, and then after that we gain the benefits. We gain more and we catch more fish, and we returning the condition of the fish before the dam was constructed. I think that's all my presentation today, and I would like to acknowledge all my supervisor that guide me so far until my 30 years today, and also Diana Duffy and then Dr. Ryan Robinson and other colleagues, that also my boss, Dr. Arif Ibowo, and also Dr. Sukanan Fahmi in my office, and also all the sponsors that provide the fund for our research. Thank you so much, and I hand over to Mr. Kuko. Thank you so much.
Yeah, thank you very much, Mr. Duat Menarso, Mr. Arso, for giving such informative and interesting presentation. Is nice knowledge from the Mr. Arso presentation. We know, or we mentioned that how important to build a fish species in the reservoir or in the dam, but we sometimes, not only sometimes, in Indonesia we forget it to know how important to build the fish species, because we always concentration in marine fish. Sometimes we forget how important inland fisheries to stability the ecosystem in and now we become to a discussion session to all the participants. If you wanna ask to the speaker, you can write your question in the chat box in the Zoom meeting, or in YouTube you can write your question in the live chat, or maybe if you want to ask directly, you can raise your hand in the Zoom meeting and you can ask to Mr. Joachim or Mr. Arso. No problem if you want to ask with bahasa. I want to help all of you to deliver to Mr. Joachim and Mr. Arso. I'm very interested, Mr. Joachim and Mr. Arso. Sometimes we forget it to how important and sometimes forget how the important things about the inland fisheries to the stability ecosystem. Mr. Arso show that we lost some species. Sometimes the effect of development, and in inland fisheries, I read that maybe not only the impact of the development of the reservoir, the dam, but also invasive species in the river or in the dam. So after this online seminar, we should remember how important that. And oh, there is two participants to ask directly, please. Who is the first raise hand? Maybe Nila.
Me, Mr.
Okay, please
Hello,
introduce
everyone.
yourself, Nila.
Yes, my name is Nila Padana Pisa. I'm from Management Research. I want to ask from Mr. Josim. So I want to ask question is, I read about drip irrigation recently, and which is the method of that efficiently utilizes water and at the same time maintain or even enhance yield by constantly dripping water on crops like a drip coffee, if you will. In contrast to the traditional method, which is a flood irrigation, I would like to know your thought on the strategy. If this, if this is truly of the solution, what are are its limitation with agriculture withdrawing roughly around 70% of water, and is a major factor that contributes to impending water scarcity. Why is this approach not yet globally implemented? Thank you.
Yeah, thank you very much, Nila. Mr. Joachim, you
Yes,
want answer it?
I hope I got the question the right way.
Yeah.
So the
Yeah.
question was whether the solution of fish screens, whether it has effect on the agriculture, is right?
Yeah.
Okay. No,
Yes.
the good thing is that fish screens are just they deliver the same amount of water. So when we're talking about a pump, the pump usually takes the water out but has no protection there. So all the fish and all goes out. And when we put just a mesh there to say, oh, we don't want to get all the fish and all the dirt in our irrigation system, then it will not work because it will block. But a fish screen just is like a big surface with lower flow, and it gives the same amount of water. The only thing, of course, you have to think about is it costs money to build it. So that's the big discussion. But on the other hand, for a long term, it saves money. So that's, I can talk for Australia now. It saves money because the people need less money to clean the pump, and need less energy because they need less energy to pump the water because it's not blocked. When it's blocked, you need more energy to pump the same amount of water. And these fish screens, it's a great thing. They save the fish, but also keep it clean. So yeah, you don't have any advantages of that. And in the United States, for example, some of the rivers are screened now for 70 years, and it has not any effect on the agriculture there. It's just an investment. That's the point. So you have to invest more and cannot just pump the water out. So you have to invest in a fish screen. But yeah, that's right at the beginning here as well in Australia. So yeah, we will see what the future brings about that. But it's definitely an important part of the puzzle of protecting fish and maintain fisheries.
Okay, thank you, Mr.
You're welcome.
Yeah. And I see Dwi Andri, you raise your hand. You want to ask to the speaker?
Thanks for the opportunity. My time is clear enough.
I think you should up your volume of your voice.
Okay. Let me introduce myself. I am Dwi Andri Chewluda, and I am undergraduate student Aquatic Resource Management 2021. I want to ask for Mr. Josim. Mr. Josim tell about his protection screen using scale berries designed to exclude fish, debris, and other organics. And for human use, are his screen protections suitable for all types of water, especially in Indonesia and Australia? And if yes, what is percentage And if not, what are the inhibiting factors? Thank you.
Okay, hello. First off, whether fish protection screens are available for all kind of water offtakes in Indonesia and Australia. That was the first part of the question, right?
Yes.
So actually, it is possible to screen every offtake, whether it is a gravity fed or is a pump offtake. But of course, you can't say we screen all offtakes because it's impossible. But I think it's important to look on the offtakes that have a high impact on fish. So where a high number of fish, or when they are in areas where a lot of fish migration is, there it makes sense to think about putting a fish screen on. And yeah, especially these diversions and pumps that end up in watering where fish can't survive. That's the important ones we should think about considering to screen, because there are some irrigation channels, for example, that provide good habitat for fish, where fish can even live in it and are even able to reproduce. Like I showed, for example, in this flooding that is often in Indonesia, they provide often good habitat for some species. But the irrigation channels, like we have them in Australia, often are just like a plastic, some plastic, and fish can't live in that. And these are the important ones we have to screen. But yes, you can screen every pump theoretically, as I showed you this huge fish screen in the USA, but also this just the small pumps or gravity fed channels. It's just, of course, always some are very complicated, some are less complicated to screen. Because some are very big, of course, and that makes it very expensive as well.
Yeah.
Well,
Thanks, Mr. Kasim.
you're welcome. Thank you.
Okay, for the next question, in the chat box in the Zoom, it's from Zulfa Milatia, from Universitasdiponegoro, asked to Mr. Arso. She asked that about the material presented by Mr. Arso regarding several weaknesses of existing fish species installed in Indonesia. In the picture of the dam in Poso, it is stated that it only would migrate upstream due to high turbulence so that other fish cannot pass through. Does this apply to downstream migration, or can other fish besides be able to pass through the fish species which will migrate downstream? Are there any morphology change fish species to fish spacing through the fish species due to high turbulence?
Thank you, Pak Kuku. Thank you for Ibu Sulfa. Yeah. Yes. So when we see the picture that I saw before, that the fish space installed in Indonesia is not suited for the local fish community, and I explained before that fish space in Poso is not appropriate, even though that's only for upstream migration of eels, not for the downstream. So that way you can see the population of eels in Poso is declining significantly. Also, if the turbulence is very high, then yeah, you're right. They can experience, I explained before about the barotrauma. So if there is too much pressure on the body, and then they will impact the swimming bladders and also the internal organ of fish, and they cannot live longer after that. So this is very important to provide the not very steep fish passage, but a little bit gradual slope, so that the head loss between the baffle is not really high and not much energy that's needed for migrate both upstream and downstream. I think that's it. Is it answer your questions?
Yeah, Mr. Arso. And this is the other question from Dwi Prayitno. I don't know, is it for you, Mr. Arso, or Mr. Joachim, or both of you can ask this question. The question from Dwi Prayitno, is it possible, considering that the existing dam is a profitable core business, there is charge with making a hatchery to supply seed of target species so that they are sustainable in nature?
Yeah, maybe I can answer. So yeah, it's happening in Indonesia, Joachim. So when they build dams specifically they create the new lakes and still water, and then people what's called create a new business for floating cage, and most often are not native species. It's just like tilapia and that. So they asking that, is it correlated with the core of the business? So he asking, are there any correlation between the hatchery system business and also the dams? So I think it's not, because fisheries, culture fisheries in the dams is, I think it's not the core of the business, but the business is to providing electricity, tourism, and also for, I think, water supply or irrigation. I think some berries is single purpose, but other is multi-purpose. They can be for irrigation, hydropower, or water supply. But I think it's not for fisheries. Absolutely, I thought that's not for fisheries. Thank you. Hopefully answer your questions.
Yeah, thank you very much, Arso. Yeah, Joachim.
So what I know from the dams from other parts of the world, the biggest problem is that they affect the flow and the migration, and some species then, like these non-native species, can deal with the situations, while the non-native species have problems. So because they cannot migrate anymore and their life cycle is affected. So these are several things coming together and affected. But yeah, I go with Dewey in this case as well. But of course, it's always several factors. But we have to think about, if you change a river completely with the dam, it's a completely new ecosystem. The whole life cycle of the species is affected, and that's what we have to think about. And that's why, for example, fish ladders can help a lot there. Yeah, that's it from my side.
Okay, thank you very much, Mr. Arso and Mr. Joachim, for the answer. I think can answer from question from Dwi Prayitno. And there is other participant raise your hand. I think I saw Adam Prayuda.
Hello, Pak Dwi and Mr. Joachim.
Hello.
I'm Adam. Yes, I'm graduate from Diponegoro University, and I right now reside in Thailand, and I proceed in environment development and sustainability. And I want to propose a question about, at first, how to eradicate of the siltation in the watershed, and the second, how the implementation and policy to advise for our government, because our government is lack of treatment to control, and how to empowerment with our society, because if we let of the case, our watershed is drop year by year. And what is your advice right now to our government policy? Thank you.
Sorry, can you repeat the first question again? I just missed that one.
Oh yeah. At first, I want to know about your treatment about the siltation in Indonesia, because you have many sedimentation and siltation, and I think in the land, if your barrier is dropped, sea level rise is renowned in Indonesia, and how to control. Maybe you can propose like empowerment to our society. It is very important in the future and sustainability. Thank you.
Well, yeah, first of all, actually what I know about what is in Indonesia with the water need and all this, I take this from literature. I personally haven't a chance to make my own picture of this there, but I would love to. So when I can talk for European and Australian watersheds mainly. But what I can tell is that especially in many rivers, the problem was this was not considered at all, and it affected the communities because there were also the fisheries was a very important factor of that. And when then there are good examples, for example, of Pakistan, where irrigation was not considering the fisheries and built a dam, and they took a lot of water, and of course it affected the communities a lot in the end because it was not considered. So there are, of course, you cannot say like when I would say, oh, we put fish screens everywhere and then it's all good. It's not that easy, unfortunately, but it might be one small, yes, as like to say, piece of the whole puzzle of getting a sustainable fisheries and also agriculture as well. That's a difficult task for all of us. So yeah, sorry if I could not give you more detailed answer for your question, but of course I'm very interested in for the future how it goes in Indonesia, as we see 65 more new dams. So and also in many other countries of the world, irrigation will rise when we need the water, but we also need the fish because it's very important. So yeah, it's a difficult task to find the balance between both to manage this, and for the managers this is the biggest task. So yeah.
How about Mr. Dwi about the police in Indonesia?
Okay, thank you, Pak Adam. So actually at the moment we have Asia project and also Australian Water Partnership that we partner between government and then NGO. We also collaborate with food and agriculture organization through IFIS project to socialize. The beginning is to socialize the importance of maintaining connectivity in the river. So we have a set project in West Java province actually at the moment to develop together between biologists from fisheries people and also from engineers. So they want to build Cibarenu irrigation system in, I think in Tasikmalaya or sorry, in Sukabumi. So we work together to provide a good fishway that considering the local fish community. So at the moment we exploring the biodiversity and the fish migration pattern of every single species. They have 29 species inhabit in this river, and we hope that through providing the fishway, at least we can reduce the population decline, even though it's not enough. Like Joachim said, that we need to have a screen to protect fish that suck to the irrigation system, and also others impact, because when they block the river, it's new ecosystem, as Joachim said, and not only fishway and screen, but also we need to consider other things such as social and economic of the people. So we need maybe to create others. So maybe we can have tourism in fishway, so people can have a look how many species can migrate upstream and downstream. Yeah, we don't know. Yeah, I hope this answer your questions.
How we need to link it about society and government, maybe have surveillance with NGO, maybe?
Yeah, of course, we have to consider all the stakeholders that need the water. So every single stakeholder we have to take care, not only fisheries, but also maybe in industry and also other things. So many stakeholders involved in water resource.
And that's the important thing, that fish biologists, engineers, social scientists, agriculture experts work together in this. So it's like with the fish screens, for example, my supervisor always says no one can sell a fish screen as good as a farmer that is using a fish screen, because he knows the advantages of it. Well, when you come as fisheries person and say, oh, you have to put a fish screen on because blah, 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 it's difficult to understand. Or you have to put a fish ladder there because it is what it is. But when the people see the advantages of it and it all comes together, then it works. And that's very important, while different stakeholders have to be involved in these processes. Yeah.
Thank you very much.
Thank you, Adam.
Thank you, Mr. Adam, for your question to all of the speakers. And then we continue to other question from Royhan Maulana. Oh, I think before we continue to Royhan Maulana, I'm sorry, we have a question from YouTube to Mr. Joachim. Do you consider the flood areas as a parameter in your model? Question from Winhard Tampubolon.
The flood parameters in my model. So yeah. I only investigate pumps and gravity fed channels. So the flooding is therefore not of efficient. But what is, of course, important to consider, as Studi already said, when we have floodings and high water on it animates many fish to migrate. So this should also be considered, of course. But I only look for pumps and gravity fed diversion. So the flooding has no direct impact on my research.
Okay,
I hope this is answering the question.
Yeah, he followed this on online seminar from YouTube. Yeah. And now we continue to other question from Rayhan. The question is for you again, Mr. Joachim. He asks, regarding fish screen pump treatment, are there any other factors that underlie the performance of this method other than the living habits of fish and fish species in their respective location, such as human factors, physical factors, or of water quality or others?
Well, actually, let's say it like that. Just depending on what we have in the river, that can get sucked out. So when we have a healthy river that is without any dams, where is a lot of migration and a stable fish populations, of course the pump has then a higher effect on it. But as already said, fish conservation and population management can be very difficult because we have all these factors. In my case, actually, the pumps are running at the gravity fed regardless the water quality, because the water is needed. So when we have a healthy river, it's always better, of course. But from my point of view, I focus on the water that is extracted and what is in that water and how many fish are affected of that, what is getting sucked out. So of course we have to look on water quality, we have to look on the migration possibility for the species, and then we also have to look on the extraction of fish. So it's one part of several parts to have a healthy and sustainable fisheries in the rivers. Because when we, let's say, we remove all the pumps of the river, or we don't do irrigation anymore, but there are like 3 dams for hydropower, it has no effect. On the other hand, if we have a healthy fish population and set many pumps and gravity diversions and take a lot of water out without any protection, then we also affect the fish population. So it's always several factors that is important for this. And my research is only on this little piece, but all together, are actually the complete puzzle.
Yeah, thank you very much.
You're welcome.
Jim, for your answer. I think this topic is so interesting. It's so many questions to Mr. Joachim and Mr. Arso, how such as technically or the modeling and the effect as well. Me, it's so interesting too, because from this seminar, I mentioned before how important to the inland fisheries. Okay, there is other question from Mr. Widya. For you, Mr. Joachim, does the government of NSW also maintain or protect the spawning ground, like a fish larvae, from palm extraction? And would you comment on this stuff that particularly fish screen is a bit less effective since it depends on the selectivity of the screen? Selectivity is mostly low as targeting more on economic species or large size. Perhaps it is more useful for catadromous species than anadromous. And then the other question for Mr. Joachim and Mr. Arso, eventually dealing stock on freshwater fisheries is more challenging since it takes more efforts, costly to protect the ecosystem. Should we give up by just maintaining fish farming with irrigation channel that is focused more for consumed species? Yeah, there is question for Mr. Jim and Mr. Arso.
Very, very interesting questions, first of all. So yeah, to question 1, yes, the New South Wales government, New South Wales Fisheries started a lot to talk with farmers, and they did a lot of measures in the rivers, like relogging, where they brought back big dead trees into the rivers as habitat for fish. And now actually they want to go on with the fish screening. So it's just a few years ago that the first big fish screen or larger screen was set, and it's getting more and more. There's actually also a homepage that shows the progress of this, if someone is interested in this. And they of course also should protect the larvae, but as I said, it's the most difficult thing to protect the larvae, because they are the smallest part, the weakest swimmers compared to big fish. But yeah, with the velocity, it is estimated that about 90% of less, so we can reduce the entrainment about 90%. You never have 100% protection, but 90% is a very good number, I think. And these are just, we see it in the US, how good these fish screens have effect on the fish populations. So yeah, there's a lot of going on, and there will be more screens built, and also for, especially for farmers, like showing them this technology and giving them the advantages of it. And the second question, well, I wouldn't say so, because so with the selectivity, because yeah, that's when we have the old thinking that there are more selectivity on economic important species, large species. But that's the good thing with the velocity. We know from studies from Australian fish how strong their swimming ability is. There was in flumes, and it was tested how fast this fish can swim and when they are not able to swim anymore. And with these fish screens reduce the velocity that much when they are working correct, that the fish can swim away from it easily, or can even swim around the fish screens without getting extracted, because we have a larger surface. So therefore, I also wouldn't say that there is a difference between catadromous and anadromous species. So I am working only on potadromous species, because I'm far away from the sea, and there are so many dams. So I'm focusing on only freshwater species. So this makes no difference. The important thing is to reduce the entrainment of the fish numbers by having low velocities at the offtakes. And therefore this works for almost all fish. Of course, we have weak swimmers and strong swimmers. But the good thing is also the small bodied species, which are not commercially important, are protected by this. Yeah, and now I do the last question, and Dewey can say what he thinks about it. Yeah. So with the stock on freshwater fisheries, it's more challenging and it takes more effort. That's the question. If we only say we focus on farming the fish we want, it won't work on a long term, because we need healthy rivers for several factors. So we can say, oh, we only do aquaculture in the irrigation channels, and what is in the river with the fish, we don't mind. But this has in several points hard to discuss, because fish should be like something everyone should be available to get. So only the people farming the fish and at the irrigation channels have that. And when we have healthy rivers with healthy fish stocks, it's a good situation for everyone. So for a more and also for of course I studied nature conservation. So from this point of view, it's also important that we have a better biodiversity, because more biodiversity means more benefits for all of us. So therefore, I would say we should prefer to focus on our rivers to keep them healthy and have healthy fish stocks in there, and not bringing the fish consume only out of the fish farming in the irrigation channel. I guess I hope that's answering the question. Dwi, what do you say?
Yeah. Thank you, Widya Nugroho. He's my friend actually. So,
Nice.
Yeah, so it's my friend when I was undergraduate. David is spent long time in Europe, and so that's very good question. And yeah, it's very not easy to answer actually. Whether we have to just give up with what's happening because it's too much effort to protect the native fish population. But as Joachim said, I agree with you that it's not only about the species, but also the health of the system. So when we just give up, and then all the system is changes, and if we have only less biodiversity, and there's a high chance to reduce in terms of genetic diversity. So if you have less population and less species, then it's high chance to you lose everything in the end. It's very easy to lose, because if population is less, and then there's some bottleneck, and then they mix only one population, and there's low diversity and easy to go to extinct. Also, if you see the invasive species in Indonesia, like tilapia, that this species only, I think, growing very well only in inundated area, like lake that created from the berries, but not in the main river. So we can, I think we can still protect our, even though there's many river is blocked by the berry, but we still have at least several that we can maintain the health of those river. And also, I think hopefully that's answer your question, Vivit.
Yeah, thank you very much, Mr. Joachim and Mr. Arso, for your answer from question from Mr. Wiwit and also your friend. Okay, for the next question from our student Ahmad Baharudin to Mr. Arso. He asked, can fires like what was done in the Snowy Hydro 2.0 project in Indonesia? Because at this time, waters in Indonesia have been polluted, one of them by disease. Then, does the use of UV screen have any effect on the quality of the fish produced?
Okay, thank you, Pak Ahmad. Yeah, that's a good question actually. Yeah, whether UV screen can be used in Indonesia? I think yeah, we can use UV screen for hydro pumps. But we need to have a deep study why we use that one. Is it only for disease that happening in all the species or not? Because in my previous presentation, I saw that when Australian government construct the Snowy Hydro 2.0 that connected to dams Talbingo and Tantangara, then they expected that redfin, which is invasive species from Europe, can bring disease that can enter to others dam, which is inhabited by the last population of, what's the name, Joachim? I forget. The small species that inhabit in Tantangara.
It's
Galaxias.
yeah, it's a Galaxias Tangarada.
So yeah, that's really, and the Australian government is really concerned about protecting Galaxias species in Tantangara. So that's why not only providing the appropriate fish screen, but also considering the UV screen if they still can enter, but yeah, at least they didn't bring the UV. The second question is it impact to the fish quality? I don't know. Maybe Joachim, you can help me to answer this one.
What's with fish quality? What kind of fish? Or so?
Maybe the health of fish after they pass to the UV screen. Is it any impact?
Well, I mean, when the screen is working, it shouldn't have a good working screen shouldn't have any effect. When a screen is bad and the flows are too high, the fish are like impinged, we call it. So when the flow is too high, and then the fish will die there or will not survive. But the aim of a good fish screen is that the fish will not get impinged. It could even swim along on the screen without getting entrained. So modern fish screens shouldn't have any.
How about the ultraviolet screen? So if
you mean the longevity or whether it affects the screen when fish?
The ultraviolet. So I saw that I put in my presentation that the New South Wales government will provide UV, so ultraviolet screen for
so
bring by.
That's another thing that was often done before, like behavioral screens, we call that. So you're working with light, you're working with noise, you're working with different behavioral things that should get fish away from offtakes, hydropower, irrigation, whatever. But finally, the studies showed that the physical barriers, so a fish screen is always more effective than a behavioral barrier. But the best would be, of course, you have both, like light or noise that gets away the fish plus the screen. That's not, of course, that's the safest thing, but it's also the most expensive one. So for hydropower stations, there was a lot of research for the cooling water offtakes, and many are working with behavioral barriers, but they're never as effective as a physical barrier, so as a fish screen.
Thank you.
You're welcome.
Yeah, thank you very much, Mr. Joachim and Mr. Arso, for your answer question from Ahmad Baharudin. I wondering to ask question for both of you. As we know, in Indonesia, the dam is to control the flow. When like at this time, when rainy season, especially in Semarang, we have two canal, West Canal flood and East Canal. And I think not only in Semarang, in Jakarta maybe. How the impact of this fish species when the raining season like this? Is it what we call distract the fish to throw the fish?
Yeah, actually, yeah, Indonesia is experiencing high flood during wet season, and so the variety of waters rain is vary during the year. So one of the solution is to provide flood kit, like installed in Jakarta and also in Semarang, so to reduce the intensity of flood. So yeah, the problem is we need to provide the ways for fish to migrate, and we need to consider not only 1 year data of river flow, but also multiple years. So to know so like in Indonesia, we have like very high rainfall every 5 years, I think. So every 5 years we have very big raining and flooding everywhere. So this species must be considered the highest rainfall and also the lowest one. So we also have experience very dry every few years. Yeah. So that's not easy task actually, and yeah, in compared to the country who has very what's called not the difference between highest rainfall and lowest is not far, so it's much easier to design. And also we also dealing with so many species that we have to consider. Yeah. So yes, so it's not easy task, but we still have to optimistic. Yeah. Maybe Joachim, you have another thought?
Yeah, I mean, as you said, it's very challenging, of course, in Indonesia with this high number of species. I mean, we're here in Australia, we're talking about 46 native species, and it's already difficult. And this number of species makes it not easier, right? So yeah, it's also, of course, naturally in these rivers, when we have very wet years, they are often also very productive for many species because we have more flood plains, means more food, very productive fish years then, so naturally. But since we have our dams and gates everywhere now, we of course affecting this natural cycle. But nevertheless, with when we have a lot of rain and water that comes suddenly, it always there are also interesting studies about these sluice gates and how on fish mortality and this I think there's still a lot to learn, and there's still a lot we don't know and we should know for the future. But that's good that there are many tasks to study and to think about as well. So yeah, it's very complex. Riverine ecology is very complex, and fish ecology to think about all the different influences we have. So Yeah.
Yeah, thank you very much, Mr. Jojo. I think both of you, not only Mr. Arso, Mr. Jojo, you should come to Indonesia to. I think we can meet in person and we study together to know how the impact, because in this period our government develop or construct more dam to the reasoning is to for irrigation and like Mr. Arso said to electricity, and yeah, because of that we sometimes we forget the important can be affect the fish inland fish ecosystem.
Yeah.
Okay.
Of course, it would be a pleasure. It would be a pleasure to come over.
Yeah.
I mean, when you think in I always think about Northern America, because there was this man and he said it, but we never would think ever about, in the 70 years ago, we never were thinking about dam removal. So taking away dams, this happens at the moment in Europe, it happens in Northern America, because the rivers are at a point, the fish disappear, there are no fish anymore, and the dam is not needed anymore from this point there. So they decide to get rid of the dam. But 50 years ago, this was like, never this would happen. And in other parts of the world, people need dams, so think, yeah, we need dams. So it's an interesting topic. Yeah. And I would be keen to come to Indonesia and take a look there on the rivers and fish. Yeah, always. Thank you so much.
Yeah, and don't forget come to Semarang, Mr. Joachim.
Thanks, Kuku.
Okay. Because the time, we finally come to the end part of this seminar. I think before I close the online seminar, we will hear closing statement, a little bit closing statement from two speakers about this topic of online seminar. Maybe first come to Mr. Joachim.
So the final outcome of this online seminar, or sorry,
yeah,
maybe you can start to maybe.
Final statement.
Final statement.
Yeah.
Well, final statement is maintaining fisheries in is very in developing watershed is very complicated and difficult and sometimes overwhelming, but it's important that we do it because we need healthy rivers, we need healthy fish communities and populations, because we all will benefit out of it. And yeah, a lot was done during the last 100 years, and there will be more. So yeah, it's good that that we all think about it and continue with it.
Yeah. Okay. How about Mr. Arso? Your closing statement of this topic.
To make a statement. So it's
very
complicated, but I believe that not only the government but also all the stakeholders will soon they will aware to protect the inland fisheries, because we have 1,300 freshwater fishes, and if we check at the moment, maybe a half or maybe, so we need to aware about our what's called so it's really important to protect not only marine fish but also inland fisheries, because there's so many pressures that come to the inland fisheries and less consider. And I hope that in the near future that inland fisheries will be more considered in government decision. I think that's all my statement. Thank you.
Yeah, thank you very much, Mr. Joachim and Mr. Arso. And I think the important thing we should remember, maybe someday, if we don't consider about this topic, I think, can affect to us, can affect to the humanity, to stability of this ecosystem. Not only this ecosystem, I think the stability of this world. Yeah. Okay. Before I close this seminar today, I would like to take the conclusion from what the speaker have presented. From Mr. Joachim, you mentioned that many irrigation projects are proceeding without considering potential impact on fisheries, and understanding how irrigation system affect fish is paramount to developing effective solution, and it may be worth considering physical barriers to divert fish away from areas concerned. So irrigation development has an impact on the stability of freshwater fish ecosystem. Therefore, irrigation development must also consider and maintain the sustainability of freshwater fish ecosystem by adding some additional tools or engineering in the irrigation to ensure the freshwater fish ecosystem is not disturbed. And from Mr. Arso, it is very important when building irrigation reservoirs or dams to attention to the impact on the freshwater fish ecosystem. It must be follow the construction of fish species and related to the design and content. We must attention to the aspect like biology, hydrology, and hydraulics. Okay, ladies and gentlemen, I close this session. I would like to apologize if there are any mistakes from me as a moderator during this session. And also, I would like to thank you so much for Mr. Joachim and Mr. Arso for your informative and interesting presentation for this online seminar today. And also to all participants for very active participation. Hopefully, this online seminar will be beneficial for us, for everybody. And please give applause to remarkable speakers today, Mr. Joachim and Mr. Arso. Thank you very much, Mr. Joachim, Mr.
Thank you very
Arso,
much
and
for the
for
inviting.
all of the participants. Yeah, I'm really appreciate and very grateful for being moderator in the online seminar. And I will return online seminar to MC Hanan. Hanan?
Okay, thank you so much, Mr. Kuku, as our moderator for lead today's online seminar, and also both of our awesome speaker, Mr. Joachim and Mr. Dwi, for delivered the presentations in their newest research. And here we are. At this moment, we have reached the closing for today's online seminar. I really do appreciate for your attendance and excitement in this today online seminar, despite the busy schedule that you guys have. Not forget to mention the Prof. Triwinarni, Ibu Dr. Suryanti, Ibu Churun Ain, and all of the lecturers and staff that cannot be mentioned one by one to spare your precious time. But before I end it, I have some additional online seminar. Maybe some committee can help me for share screen. Okay. All right, in here we have some certificate as an appreciations for Mr. Joachim Bendit Bretzel, MSc PhD candidate.
Thank you very much.
And for, yes, and the second one is for Mr. Dwi Adminarso, PhD candidate. This is from our, yes, you're welcome, Mr. All right. And the last one is for Mr. Kuku Prakoso as our moderator today.
Thank you very much, Hanan and the committee.
Sure. Okay, and here we have some attendance form. You can kindly check the chat box column because the committee already prepared for the link below. So And for the e-certificate, you can access by this link. Okay, next slide, please. Okay, so this is what I told before, that we have some additional informations for upcoming event. That is an online seminar also, that the theme is effects of climate changes on marine biodiversity and coastal ecosystem. And the speaker is Prof. Masiro Nakoaka, PhD. He is from Akechi Marine Stations from Hokkaido University, Japan. So maybe all of the participants can join and attend this online seminar that will be held on Tuesday, November 16, 2021, 1 until 3 p.m. Indonesian Western Time. Next, please. And don't forget to check out our online platform. We have some Instagram for additional information, that is online seminar, and you can follow us on at MSP_FPIK Undip. And don't forget to subscribe our YouTube, that is official Departemen Sumberdaya Akuatik FPIK Undip. And also our website, you can visit at https://aquaticfpikundip.ac.id. And you can contact our email on seminar.msp.undip@gmail.com. Okay, so see you again, guys, in the next online seminar. I, as a master of ceremony, apologize if there are any mispronounced or mistake in delivering today's sessions. Keep updated and check our social media for upcoming event. I'm Hanan Azahra, as today master of ceremony, standing back. Thank you, and see you in another change. Stay safe and healthy, everyone. Goodbye.
Bye.
Thank you so much. Goodbye.
Thank you, Mr. Joachim.
Terima kasih, Mas Kuko.
Terima kasih,
So,
Mr. Hanan. Arso, terima kasih, Mr. Jod. Nice to meet you.